In this video, we are going to study a concept called the work done. It is a type of energy, but not necessarily is mainly a concept. And we measure work done in joules. Okay. So, yep. Now, let me give you an example first. Okay. Say if I have an elephant. And this elephant is pushing against a wall. He tried as hard as he could. He used all his energy in the body. He tried to push the wall, and the wall doesn't move. So, in this scenario, in physics, we considered this as no work done. The elephant did no work on the wall. Okay. It doesn't matter how tired he is, he did no work. Now, in contrast, if I have Mr. Zhao here standing beside a table, and I am pushing a pencil. Then if the pencil moved 3 centimeters, now in the world of physics, this is considered as Mr. Zhao did some work. Okay. So, ironically, compared with the elephant, I did some work. So I can say that I did more work than the elephant. But how exactly does work done can be measured in physics? Now let me introduce you guys some equations. So work done has a unit of joules. It's measured as the change of kinetic energy. So if you look at the scenario with the elephant on the top, the elephant is trying his best pushing the wall, and the wall doesn't move. If the wall doesn't move, it doesn't have a speed, so there's no work done. However, when I try to push a pencil on a table, the pencil moved. It moved with a speed, thus there is a change in kinetic energy, thus I did some work. Okay, and it is now work done is the change in kinetic energy, and it is basically equal to force times the distance it moved. Okay, now let's look at a question. Okay, so in this question, I am pushing an object. I applied 10 newtons force on it, and over a distance of 7 meters. Okay. So the idea is the object moved 7 meters. So question A is asking, what is the work done? Okay. So remember your golden formula. The work done is the change in kinetic energy is basically force times the distance. Okay, so now just putting down the values in. Okay, now I applied 10 Newton of force over 7 meters of distance. So the work done must be 10 times 7, which is 70 joules in this case. For question B, we need to find the kinetic energy. Oh, sorry. Basically, I need to find the speed of the box afterwards. Now, just remember, work done is the change in kinetic energy, which is 70 joules in this case. Okay, so the change in kinetic energy is 70 joules. The change in kinetic energy is always the change in something is always measured in the kinetic energy afterwards, final, take away the kinetic energy initial, which is 70 joules. Okay. So initially, let's assume the box is stationary, so the final kinetic energy of the box or the object is going to be 70 joules. So let me rewrite it properly. Yep. So the initial kinetic energy is 0. Okay. And we know the final kinetic energy must be 70 joules. Okay. In other words, I applied 70 joules to the box. Okay. Now the equation of kinetic energy is half mv square equals to 70 joules, so I can easily find out the velocity. Okay. But in this scenario, I need the mass, right? Because I need to find the mass of the object, okay. And this is my mistake. I forgot to basically I forgot to write it down. Okay, so I write it down now. Say if the mass of the object is 10 kilogram, I just assume it is 10 kilogram. Yep, it should be included in the question. I just didn't write it down. Okay, then let's put down all the values. I have half times 10 times v square equals to 70. So I have 5v square equals to 70. V square equals to 35. Okay. I do my calculation. Velocity will be square root of 35, which is going to be, say, square root of 35, 5.9. Okay, 5.9 meters per second. Okay, this is down. So yeah, this is a classic example of work done and kinetic energy. Now, the important thing I need you to remember will be this. Okay, will be the formula. Okay. Work done is the change in kinetic energy is basically force times the distance. And yep. Okay, so yep. Just remember this. Looking at the equation, especially this part, the change in kinetic energy in equals to force times distance. Now, the reason this equation is very important is this equation relates energy and force together. Okay. This is why work done is really important, because the work done equation relate force, which is measured in newtons, with energy, which is measured in joules. So put always remember this, okay, especially the change in kinetic energy part. It will be helpful.